Jai Hind everyone. I am Dr. Ashima, working as assistant professor in Computer Science and Engineering Department, Swami Vivekanand Subharti University, Meerut. I am here to present the topic data structure and algorithm using C++. Let's start with the definition. Firstly, as what is data structure? In Hindi terms, we can say that data is a collection of information and in which we can collect the information, the values in integer form or in float form or in character form. We can organize these information in any of the structure, that is called data structure. So firstly, we have to collect and organizing data. What is data structure? Collect and organizing data in such a way that perform operations. Which type of operations we can perform? We can perform insert operation, delete operation, search operation, sort operation. There are a lot of different operations we can perform in any of the structure to make the data effective. So the thing, data structure are the structure programmed to store data or in an ordered way so that we can easily perform the different operations, and it should be designed and implemented in such a way that it reduces firstly complexity and increase the efficiency. We all know that we have to perform the data so that complexity will be reduced and the efficiency will be increased. Then let's start with the next definition. Start with the characteristics of data structure. First characteristic is correctness. Data structure implementation should be implemented in an interface correctly. Time complexity. Running time complexity or the execution time of the operation of the data structure must be small as possible. Space complexity. Memory usage of the data structure operation should be as little as possible. So, if we want to save the memory, firstly we will reduce the complexity. That's the main reason we will use data structure. These are the three characteristics of data structure. Next, need of data structure. Why we need this? Data search. As we all know that there are lot of data all over the computer and we have to search the precise data in a particular structure. Consider an inventory of 1,106 items to store. An inventory which having a 1,106 items to store. If an application is to search an item, it has to search a 1,000,000 items. As data grows, search will become slower. As we all know that if there is a huge data, then the searching capabilities can be reduced. So reduce the complexity of searching, we can use the data structure. Processor speed. Processor speed, although being very high, false definition if the data grows to billion records. Multiple requests. As thousands of users can search data simultaneously on the web server, fast server fails the searching data. There are, as we already discussed, there are a lot of operations we can perform on the data structure. First one is search. Algorithm to search an item in a data structure. Sort. Algorithm to sort item in a certain order. Insert. Algorithm to insert a new item in a data structure. Update. We can update easily the existing data in the data structure. Delete. We can delete an element in the existing data. Let's discuss the types of data structure. There are two types of data structure. First one is linear data structure and second one is non-linear data structure. As name specified that what is linear data structure, in which data is arranged in a sequence order, or in non-linear data structure data is in the form of graphs, is in the form of trees, means a hierarchical structure will be formed in the non-linear data structure. In linear data structure there are different types of data structure. First one is array, second one is stack, third one is queue, fourth one is linked list, and the fifth one. After the linear data structure there are two types of non-linear data structure. First one is trees and second one is graphs. The main difference between the linear data structure and the non-linear data structure is that in this data can be stored in the sequence order, in the sequential order, or in the non-linear data structure, the data will be stored in the hierarchical. What is linear data structure? In linear data structure, the elements are arranged in the sequence one after the other. Since elements are arranged order, they are easy to implement. However, when the complexity of the program increases, linear data structure might not be the best choice because of operational complexity. Why? If we store the data in any of the linear data structure, suppose we have a array 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. We have to store the value in out of 5. Then we will firstly write down here say 5, 7, 9, 1, 2. In this we can see that first element will be 5. Then we will store here. Second element is 7. Then we will store in the second location. Third element is 9. Then store in the third location. Up to so on we can add on the elements according to the sequential order. But when we fetch the when we want to fetch the element number 9, so firstly we have to delete the element number 5, then delete the element number 7, then we can access the element number 9. Let us take an example. Firstly, we have the elements number 2, 5, 7, 9, 15. We have to arrange these elements in an array of 5 elements. Firstly, we have to give the index number 1 to 5 and store these elements 2. After that we will store here is 5, then we will store 7, then 9, then 15. Here there are 5 elements and we have stored these elements in which they are given. Firstly 2 is given, then it will be stored in the first location, then after 5 is given it will be stored in the second location, so on. 15 will be stored in the fifth location. Then we have to perform the delete operation on the element number 3, which is 7. So you have to firstly go to the number 2, then go to the number 5, then you will have to delete the number 7. There are a lot of complexity to perform the different operations. And in non-linear data structure, we can arrange the elements in the hierarchical forms. That is, trees and graph is the example of non-linear data structure. First, we will discuss the definition of linear data structure. In linear data structure, the elements are arranged in a sequence. One after the other. Since elements are arranged order, they are easy to implement. However, when the complexity of the program increases, linear data structure might not be the best choice. Why it is not be the best choice? Because if we want to perform on the different operations like delete operation, modify operation, we have to work more as compared to the non-linear data structure due to its arrangement of the sequential order. Let's discuss the popular linear data structures are. First one is array. What is array? An array, element in a memory are arranged in a continuous memory. All the elements in the array are of same type. Means if you store the integer values, then all the values are integer. We cannot combine the values with int with float or float with character. We can only choose only one type of data type to store the values in the array. Only one type of value you can access, and the type of element that can be stored in the form of array is determined the programming language. There is the index value. Index value is just like our house number. Like if we having the starting number is 0, then it will be in a sequential order. First one is 0, second one is 1, then 2, then 3 and then 4. These are the values. These are the values and these are the locations. If we discuss about the 2 is the location which we can call as index number or addressing number, or if we talk about the 5, it is the value which will be stored at the location number 2. Let us take another example of the array. if we want to calculate the length of array, suppose there is 0, 1, 2, 3, 4. If we want to calculate the length of the array, then the formula is upper bound minus lower bound plus 1. What it means? This is LB. This is upper bound. What is the range of this? Upper bound is 4. Upper bound here is 4 and lower bound is 0 plus 1. It is equals to 5. Then we can say that the length of the array is 5. Let's take another example of the array. Here we find out the length of the array. First condition, given the numbering of the index value is the number must be consecutive. Consecutive means if we start the value with 71, then its number is 72, its number is 73 and its number is 74. We have to calculate the length of the array. So, as we all know that the formula is upper bound minus lower bound plus 1. Here, what is the upper bound? That is 74. What is the lower bound? That is 71. 74 minus 71 plus 1. What is the answer? 3 plus 1 is equals to 4. Then we can calculate the length of the array. It's about the structure of array, which is of linear data structure. In this, all the data will be stored consecutively. Next, the next data structure is stack data structure. Let's take the live example of stack data structure. We all know that we have a CD storage in which it is a pipe. If we want to store the CD, then it will be firstly placed on this. After CD, this next CD will be stored in this location. So CD1 will be stored in this location. CD second will be stored in that location. CD third will be stored in the third location. We can put more and more CDs in that storage device. So if we want to remove the CD number 2, so firstly you have to remove the CD number 4 out of this. Firstly we will remove 4. Secondly we will remove 3. Then we have to delete the number 2. So for removing the value number 2, we have to firstly remove the value number 4, CD number 4 and CD number 3. Let's take another example. In this we can perform LIFO principle. What is LIFO principle? LIFO means last in, first out. Last in, first out means what? We will add last CD is 4. After that, if we want to delete, then first CD will be removed, will be 4. So last in, first out operation will be performed in the stack data structure. Will be out first. That is the last element stored in the stack will be removed first. It works just like a pile of plates where the last plate kept on the pile will be removed first. And in this example, if we want to add the element, first we will add element number 1, then 2, then 3. If we want to remove, the removal will be on the one side. Firstly out will be 3, then 2, then 1. So inserting and deleting will be at the one end. No other end will be displayed in the stack operation. All the operation will be performed only in the one end, that is your top. This is the top value, and what is this? This is top minus 1. The first upper value will be called as top value. The second value below the top is top minus. Take an example of next data structure, which is the queue data structure. What is queue? Queue is just like a stack data structure, but the difference is that we can remove and add on the both side of the element. In adding, we can use the front part, and for deleting, we will use the rear part. Unlike stack, the queue data structure works in FIFO principle. FIFO means What is FIFO? FIFO means first in, first out principle. Means the element which will be inserted first will be removed first. And it just works like a people in the ticket counter where the first person on the queue will get the ticket first. Let us take an example of the ticket counter. There is a ticket counter which is like this. There are 3 counters, 3 windows. Firstly, a person will come and add on this block. Second person will come, add on the next to the first person. Third person will come and after the second person. This is first person, this is second person, this is third person. If the first person take the ticket from this counter, then first person will be added is 1 number. And when it will take the ticket from this person, then it will remove first. First will be removed first. So in that example, we can say that 3 is the first position element, second, third. If we want to remove an element, we will remove it from the last position. That's 3 will be removed first, then we'll remove second, then it will remove third position. So in queue, we will perform the operations from both the ends. In addition and remove from the sequence end. Let's start with the next data structure, that is linked list data structure. What is linked list data structure? Linked list data structure is the part of linear data structure in which the data elements are arranged in the sequential order. In that, we can take an example that a node is divided into 2 parts. First part is info part and second part is address part. It will be the start position. If a person will start from this location, then it will come to the next node. Next node will carry the information part as well as address of the next node. Address किसका होगा उसके पास? Next node का. This is node number 1, this is node number 2, this is node number 3. So the person will carry the data structure will carry the info part as well as the address part. Address will be carry the next node address, which will be is when it give this is the link pointer that will come to the next node. Then this next node will be connected with the third node, and the pointer will connect all the nodes in the linked list. In linked list data structure, data elements are connected through a series of nodes. Series of node means number 1 node, number 2 node, number 3 node, which will be connected with the help of pointers. And each node contain data item and address to the next node. Each node is having 2 parts. First part is containing data items and second part is containing the next node address of the next node. Now start with the non-linear data structure. What is non-linear data structure? Non-linear data structure is in a hierarchical form, which is a form of graph or trees. Let's start with the first non-linear data structure, that is graph. Graph is our non-linear data structure. Example of non-linear data structure in which the elements are arranged in a hierarchical format. Unlike linear data structure, elements in non-linear data structure are not in any of the sequence. We cannot arrange the element in a sequential order. Instead of this, it will be arranged in the hierarchical order. We can say that linear data structure and non-linear data structure, the main difference is the arranging the elements. In linear, we will arrange it in a sequence form, and in non-linear, we will arrange it in a hierarchical manner. As we all know that in sequential manner, we already discussed, there is a lot of complexity to find out the data, searching the data, deleting the data, or modify any of the element in the linear data structure. But in non-linear data structure, that will be benefited for us. We can easily remove the element. And we can also update the element as we require. So that data structure is divided into graph and tree based data structure. Firstly, we will discuss about the graph data structure. Let's take about an example in which these things are called as edges, or these nodes is called as nodes. These are nodes and these are edges. all the nodes are connected with the help of edges. In the graph data structure, each node is called as vertex. Each vertex is connected to the other with the help of edges. Means all nodes we can call as vertex, and all the vertices are arranged with the help of the edges. Let's take an example. We can arrange that element like A, B, C, D. All these are the vertices of the data structure, but we can connect it in a simply with the edges. If we give it the direction, then it will be corrected as then it will be called as directed graph. It will be called as a directed graph. And if we take an example of weighted graph, we will give the 5, it's 4, it's 3, it's 2, it's 1. Then these values are known as the weights of on that edges. These are the weights. These are the weights on these edges. Means A to B edge is carrying the weight 5 and B to C carrying the weight 4. So that graph is known as directed graph as well as weighted graph. Let's take an example of another data structure. Tree is another type of data structure. In tree data structure, we are having vertices as well as edges like a graph, in which we can arrange our nodes with the help of these are the nodes and these are the edges. So we can arrange in our nodes and edges in a hierarchical format. We can add one more, but the data type will be same. It is not possible to arrange the data type of different, like here it is int, here it is character value. So firstly we will consider of the same data type. This is the wrong example of the tree data structure. If we want to add the more nodes, you have to add number 1, or you can say that we can add the 5 in the bottom, but we can't add A and B at any of the leaf node or child node. We can, here it is a root node. What is this? It is a root node. It is a child node, or we can call it as parent node, or we can call it as leaf node. So we can add the elements of the same type. Then we can add 1 and 5 in any of the vertex, but we can't add A and B in any of the vertex. So in tree data structure, we can perform different operations like inserting, deleting, updating the node, and many more. We can also search or sort the elements in the tree data structure. Next, let's talk about the main difference between the linear data structure and the non-linear data structure. As we already discussed, linear data is of sequential order on the other, but the data items in the non-linear is arranged as non-sequential. Non-sequential means it is in a hierarchical form. All the items are present on a single layer, and in this all the items are present in the different layers. As we consider in the array, stack, queue, all the elements is in a single form, but in the trees and graph we will arrange the element in the different layers. Traversed in a single run, but in the non-linear data structure we have to run it on a multiple run, because there is a layering system, but in this there is a single layer. Our memory utilization is not efficient. Why? Because we cannot easily perform the different operations in the linear data structure. We have to be take time taking, that operations will be time taking. In this we can perform easily the deletion and operations. Different structure utilize memory in different efficient way depending on the need. The time complexity increases with the data size. Time complexity remains the same. In the last example, in this the linear data structure we have array, stack and queue, and in this we have tree. Thank you so much.